So moving along now, we are going to figure out which problem this is. And so if we look at this, we're trying to find the value of x. So I'll give you a second to kind of look at it. You may notice that this one is talking about an angle bisector because we know that these two lines are the same length and they're measured at a 90-degree angle. So if they are the same length, then that would mean that this angle would be equal to that angle by our converse of our angle bisector theorem. So that means that I can set, if I need to find x, I'm going to set 7x equal to 3x plus 16. So now solving it algebraically, move my x's to the same side. I end up with 4x equaling 16. If I divide by 4, x comes out to be 4. And that's really all I needed to do. But I'm going to do a quick little check to see if I'm right. And so for this angle, if I do 7 times 4, I get 28. Here, if I take 3 times 4 and add on 16, well, 12 plus 16 is also 28, so that my angles are the same, which is what we assumed originally anyway, by the converse of the angle bisector theorem. Okay, so then the next example, it says the line BD is perpendicular bisector of AC. So they're already telling us that this is a perpendicular bisector. So we know that there's a right angle here. We know that this piece is equal to that piece because the term perpendicular means the right angle. Bisector means the pieces are the same. And so we know, knowing that, it says use the perpendicular bisector theorem to find the length of AB. AD. So, knowing that this is a perpendicular bisector, any point that I choose on the perpendicular bisector will be the same distance from that point to A as it is to C. So they picked this point D way up here, so that would mean that DC and DA will be equal to each other. So 3x plus 5 has to equal 4x. Well, subtracting 3x, following my steps of algebra, I end up with x equaling 5. And knowing that, that's not the answer to the question because they want me to find AD. So AD is this length. So to find AD, I'm saying 4 times x, which is the same as 4 times 5, which is 20. So that's the length of that side. If I was to put 5 in over here, would I get 20? Hopefully I would. Just to check, 3 times 5 plus 5 gives me 15 plus 5, which is 20, which is what we assumed originally, but it's always good to check and make sure that we're doing these correctly. So then for my next example, we have to kind of figure out what's going on. They're asking us, what is the measure of GFJ? So this is what they want to know. There's our question mark. What is the measure of that angle? So we have to decode this problem, and you'll notice that we're talking about distances from a point on a line to the sides of an angle, and we're measured at a right angle, and these two pieces are the same length. So knowing that these two pieces are the same length, I can use my converse of angle bisectors theorem, and basically knowing that, I know that this angle is the same as the angle down here because FJ is the angle bisector, so angle GFJ is equal to 36 degrees also. That's really all you had to do. You just had to recognize the theorem, and that's a lot of the problems, is trying to recognize what the theorems are. Okay, so then our next one, it says, for what value of x does P lie on the bisector of angle A? Well, we have to think back to what we know about the angle bisector and P. If we want line P to be on the angle bisector, we need to make sure, using our angle bisector theorem, that if this point is on the angle bisector, cutting this angle in half, then I would know that this distance would have to be equal to that distance. And so that's what I'm going to do. I'm going to find the value of x that makes that true. So I'm going to say x minus 3 equals 3x minus 5. So now I have to solve algebraically. First, I'm going to get my numbers on the same side. So I'm going to add 3. Actually, no, I'm going to get my numbers on the same side by adding 5 to both sides. I always like to try to move the smaller ones to the larger one side. So then I'm left with x plus 2 equals 3x. If I subtract x across the equal sign, then I get 2 equals 2x, and if I divide by 2, then x equals 1. So that's the value of x that will make this true. Well, let's see. If I put in 1 in here, that length is actually -2. If I put 1 in here, that length is -2. Doesn't make much sense, but hey, it is what it is, so that's the way we're going with it. Okay? So then we're here to the out, and it says explain why FA would be equal to FB. So again, what I notice on this one is that if FG is perpendicular to AB and AG is equal to GB, that's supposed to be a G over here, GB, then FA is equal to FB by the perpendicular bisector theorem. Perpendicular bisector theorem. And really, the whole thing is what I want is that these guys are equal because it's the perpendicular bisector theorem. But this is the information we need to know that we can see on the drawing. This is the reason. This is the answer, and so that's what we're talking about. So thank you for listening in on this webinar. I will see you guys soon, and have a good day.